Good afternoon, ladies and gentlemen. Welcome to week 28 of your SAT Math Prep. This video is intended for those Algebra 2 honor prep Algebra 2 students that did not make their SAT prep session this week so that they can watch the lesson before they attempt the skill check, which is being included in their grade. This video is also for those who want to review the material before they take the skill check to make it up or potentially even earn a better grade. Please make sure that you take all of the notes provided in this video so that you have them available to you when you're doing your skill check. So, number one says the function f is defined by a polynomial. Some values of x and f of x are shown in the table below. Which of the following must be a factor of f of x? Well, remember that we can figure out the zeros, roots, solutions, x-intercepts. These all mean the same thing. Are when f of x is equal to 0. So if we look at the table, we have one point where f of x equals 0. When x equals 4, we have ourselves a solution, a root, a 0, and x-intercept. Remember that means that x minus 4 must be a factor. So our answer here should be C. X minus 4 has to be a factor of f of x. Now there could very well be other factors, but that's the only one shown in that particular table. Okay, on to example 2. Example 2 says a graph of polynomial function g is shown. Which of the following could be the equation of g of x? So we need to remember that when an equation is in factored form, it shows us all of the possible zeros, roots, solutions, x-intercepts of the graph. So if we look at our graph here, we have three x-intercepts that are shown. We have x equals -3, which has what we call a multiplicity of 1 because it's a straight line passing through the x-axis. We have x equals 2, which is also a multiplicity of 1 because it is a straight line passing through the axis. And then we have x equals 0, which appears to have a multiplicity of 2. Anytime the graph touches the x-axis and then turns back the direction it's coming from, that implies that x equals 0 is what is called a double root. Now, it might also be a quadruple root or it basically has an even power. Okay? So, when we are looking at this, we need to think to ourselves, well, how do we get those roots? Okay, these roots, these solutions would come from factors of x plus 3 and x minus 2 would give us the roots -3 and +2. And x equals 0, remember it's multiplicity of 2, it is a double root. Okay, when we see that or we see double root, anytime it turns like that at the axis, that means there should be an exponent on the x. In this case, we're looking at an x squared situation. So our equation would have to be x squared times x plus 3 times x minus 2, which is B. Okay, choices A and C do not have a multiplicity of 2 on the x. Plus, the signs are backwards on C. And then on D, the signs are backwards. So the only choice is choice B. Okay, our third and I believe final example of this worksheet. We have the function h is defined below where a, b, c, and d are integer constants. If the zeros of this function are 5, 6, and 7, what is the value of c? So noticing that they've given us the roots, solutions, or zeros, that allows us to figure out the actual equation. If x equals -5, x equals 6, and x equals 7 are the roots, solutions, zeros, x-intercepts, that means that the factors are x plus 5, x minus 6, and x minus 7. In that case, we can multiply them out to get the original function. So h of x is equal to the product of x plus 5 times x minus 6 times x minus 7. So we don't actually have to multiply this whole thing out. I'll point that out in a minute. But if we do, we have to FOIL, which would be x squared minus 6x plus 5x minus 30. And we still have the x minus 7 hanging out at the end. Now there are some like terms there, which allows us to downsize that into a trinomial. And then we would be multiplying that out as well, which again is similar to FOILing. We need to make sure everything in the first set of parentheses multiplies everything in the second set of parentheses, which would give us x squared times x is x cubed. X squared times -7 is -7x squared. Negative x times x is negative x squared. Negative x times -7 is positive 7x. Negative 30 times x is negative 30x. Negative 30 times -7 is positive 210. Combine like terms, and we get the final exact version of h of x, which is x cubed minus 8x squared minus 23x plus 210, which if we compare it to the function they asked us about, we get our answer. C is 210, B is -23, and A is -8. Now it's worth noting that you didn't actually have to do that to get the answer 210. Okay, if we just consider the original factors here, and we look specifically at 5, -6, and -7, that is going to be the numbers that turn into this 210. When we multiply that out, to get that constant term, C, we really only need to multiply 5 times -6 times -7 to get that 210. So that would be the quicker way to get to that answer, which again, if you've got the understanding of polynomials, you can get there faster than the way that we were talking there, okay, than the multiplying it out. So anyway, the answer is 210. Now again, on the SAT, any of these open-ended questions, you have a maximum number of symbols you're allowed to type in. So we wouldn't type in C equals 210, we would just type in 210. All right, folks, that does it for the skill check. You're now able to go and do your, that does it for the notes. You can now go do your skill check. Thank you very much for your time and attention.